At first glance, this looks like ordinary farm waste, a heavy, water-filled banana pseudostem left after the fruit is harvested. But hidden inside its layered structure are long bundles of natural fiber. In the next few minutes, those wet green sheaths will be split, scraped, washed, softened, aligned, and spun, until material with little value is ready to become yarn and woven textile. A banana plant does not have a wooden trunk. What looks like one is a pseudostem, built from tightly overlapping leaf sheaths. Each fruiting pseudostem produces one bunch, and after harvest, it will not fruit again. New shoots continue the crop, while the old stem can be cut and removed. For fiber production, freshly cut pseudostems are collected before decay damages the material. The sections are trimmed, loaded, and moved quickly to the processing area. Fresh material is extremely wet and bulky, so long delays make clean extraction more difficult. At the receiving station, workers inspect the pseudostems and remove rotten, damaged, or heavily contaminated sections. Soil, loose leaves, and foreign material must stay away from the extraction line because grit can damage machinery and reduce fiber quality. The pseudostem is opened into individual sheaths. These layers are not identical. Their thickness, fiber content, color, and strength change from the outside toward the softer center, so usable sheaths can be sorted by condition and intended application. The selected material is cut into strips sized for the extractor. Consistent width matters. Uneven pieces feed poorly, overload the rollers, and leave too much pulp attached. Now the real transformation begins. A wet sheath enters the decortication system between controlled feed rollers. Rotating scraping or beating elements break away the soft plant tissue surrounding the stronger fiber bundles. Pulp and sap fall below the machine, while long strands emerge from the opposite side. The goal is not to grind the entire stem. It is to remove enough tissue without cutting, tangling, or weakening the fibers. Too little pressure leaves pulp behind. Too much pressure can shorten the strands and damage their surface. Operators monitor alignment, roller spacing, and fiber appearance as each strip passes through. Some material may need a second controlled pass, but repeated scraping is avoided once the fiber is clean. The extracted bundles are pale, wet, and stringy, with small pieces of plant tissue still trapped between them. Pulp and liquid can be collected for suitable byproduct treatment or disposal, but the process is not automatically zero waste. Moisture, organic residue, cleaning water, and energy still require responsible management. The fresh fiber now moves to washing. Clean water carries away loosened pulp, sap, and fine debris that the extractor could not remove. Gentle agitation separates the strands without turning them into knots. After rinsing, squeeze rollers press out excess water, reducing the dryer load and helping the fibers dry evenly. They are spread in thin, open layers rather than dense wet bundles. Drying may use ventilated racks, warm air chambers, or a continuous belt system. The purpose is the same: lower moisture evenly without scorching the fiber or making it brittle. When drying is complete, the strands are lighter, firmer, and easier to handle. The material has now been extracted, cleaned, and stabilized, but it is not yet ready to become soft textile yarn. The dried fiber enters the preparation department. Workers or mechanical openers loosen compacted bundles and remove remaining fragments. Combing equipment pulls the strands into a more parallel direction. Short pieces, tangled clumps, and coarse debris are separated from longer usable fiber. The aligned bundles are graded by cleanliness, color, length, fineness, and consistency. Banana varieties and pseudostem layers do not produce identical fiber, so grading prevents one poor batch from creating weak or uneven yarn. Longer, stronger material may be used for coarse yarn, cordage, or technical applications. Finer batches continue toward textile softening and spinning. Mechanical extraction exposes the fiber bundles, but natural gums and other non-cellulosic materials remain around them. These substances add stiffness and make untreated fiber difficult to separate into fine, flexible strands. To improve spinability, selected fiber undergoes controlled degumming or softening. The exact method varies. Some systems use carefully managed alkaline processing, while others use enzymes that break down pectin and related binding materials. Treatment must clean and soften the fiber without damaging the cellulose structure responsible for strength. Afterward, the fibers are thoroughly rinsed, neutralized when required, pressed, and dried again. The result is visibly different: cleaner bundles, a smoother surface, and greater flexibility. This stage separates rough extracted fiber from material that can enter textile machinery reliably. For many textile products, prepared banana fiber is cut to a controlled staple length and blended with cotton or another cellulosic fiber. Blending can improve processing consistency, softness, and yarn uniformity while retaining part of the banana fiber's character. The fibers pass through opening and carding equipment, where small tufts are separated and distributed into a thin web. The web is condensed into a loose strand called sliver. Several slivers can then be combined and drawn to improve evenness and alignment. The prepared strand enters the selected spinning system. Drafting rollers reduce its thickness, while twist locks the fibers together into continuous yarn. Sensors and operators watch for thick places, broken ends, and unstable tension. A strong raw fiber is not automatically a good yarn. Length variation, stiffness, poor blending, or incomplete degumming can cause breakage and unevenness. Stable spinning proves that the earlier stages were controlled correctly. Finished yarn packages are conditioned and sampled for testing. Technicians check yarn evenness, strength, moisture, and visible defects. Batches that fail the required standard are downgraded, reworked, or redirected. Approved yarn can now move to weaving. On the loom, lengthwise warp yarns are held under tension while filling yarn passes across them, building fabric one line at a time. The final sample represents every decision that came before it: fresh material selection, careful scraping, complete washing, even drying, controlled softening, accurate blending, and stable spinning. A discarded banana pseudostem has become clean fiber, usable yarn, and woven material, not through one miracle machine, but through a chain of precise transformations. What began as a wet stack of leaf sheaths now leaves the factory as a new industrial raw material.